Good morning. Happy Thursday, or shall I say Friday Eve. I'm going to do a really quick video because a lot of you have been having questions, being confused, trying to figure out what the heck is going on with these Punnett Squares. First thing I'm going to tell you to do is to go back to the video lesson 6.4. If you look on my matrix, it is on there. There's a link. You can just click on it. It's also here, so we're going to listen really quick. All right, so again, I'll upload that. Let me put that there so you guys can have this in the resources. It'll already be available. But anyway, what you're going to do is you are going to start a screen record for me. If you read your directions, it tells you basically we're looking at the genetic makeup of organisms in this community. Everybody knows SpongeBob and Patrick and Squidward and Mr. Krabs, but put your name on your paper, and then you are going to tell me, okay, for each genotype in number 1, you're going to tell me whether it's heterozygous, H-E, or homozygous, H-O. Pause. Please don't butcher that word. You guys had me laughing so hard at your videos trying to pronounce that word. So it's not physics or chemistry. So it's not homogeneous or heterogeneous. That's referring to a mixture, which is not what we're doing right now. The words are heterozygous, homozygous, Z-Y-G-O-U-S, zygote, hetero, homo, zygous. Again, you guys have me dying. But anyway, continue. We're going to be mature about that. Sorry, it says ho. But I want you to make sure that you are understanding this here. 2 uppercase. All right, are they the same? Most of you already got that, so I'm going to skip over that. And I'm going to get to this portion here where we start going over the actual Punnett Square itself. Zygous for his shape, hetero. Go back a little bit. Tall is going to represent it, because now what we have to do is in number 4 we have to figure out, and again this is your homework, so you should be doing, or sorry, not your homework, your classwork for Friday. Keep in mind, this is March 23rd's recording. So you're going to be making me a video just like this. SpongeBob recently met Sponge Susie. She's round, he's square. It says there, SpongeBob is heterozygous for his shape. Hetero. He's going to be a square. Heterozygous. Big S, little s. Why did I say S? Because he is a square pants. Why did I say big and little? Because he is heterozygous. And why did I put it on this side of the Punnett Square? Because that's how Punnett Squares work, like multiplication tables. But Sponge Susie is round. So our big S is going to be square. And our little s is going to be round. She has to have 2 alleles, one from mom and one from dad. Because she's round, they both have to be lowercase s's. And then we use this like a multiplication table. These go down and these go over. So we're going to have big S, little s. Why? Because I don't write my name lowercase a, capital N, G-I-E. No, I put the capital first. And then both of these come from the top and the side. So all possible genotypes, the genotypes are going to be the children. The children are what's found in the inside and the inside only. Because again, a Punnett Square shows the probability of children. So possible genotypes, big S and little s is 1, because you get one from mom and one from dad. They got the big S from SpongeBob and the little s from Sponge Susie. And then the other possible genotype is going to be little s, little s. All right, I'm going to stop there so that I can get back to what I was actually trying to do. Again, I told you you can click on and watch that video. That is on today's no, yesterday's matrix. What we are supposed to be doing is, again, just making sure that we're understanding. For tomorrow, you guys are going to be doing the monohybrid practice. This assignment I'm about to grade in a little bit. I know some of you were getting it wrong as we were going through together. The first thing, monohybrid. Mono meaning one. These are monohybrid crosses. Dihybrid would mean there are two traits or two letters. Mono, we only have one letter. That letter is B. That's it. Dihybrid, we would have A's and B's. We have not got to that. It's going to take me a while to teach you guys that, but I got you. So this is a monohybrid cross. How do we know? Because we have B's, only one letter. Genotypic ratio is written up here. It tells you homozygous dominant to heterozygous to homozygous recessive. So you're counting numbers. So how many big do you have? How many big little do you have? And how many little do you have? That's always the way the ratio is written. So that's like me asking you how many boys versus girls in a classroom. You would tell me there are 17 boys and 11 girls, or whatever the case is. In this, we had to do a Punnett with the B's. Big B, little b. That comes from here. And then little b. That comes from here. Capitals always go first. You cannot write this way. That's not right. It has to go big, little, and then little, and little. You guys should know how to fill out the boxes. Once I do that, I'm only looking at the inside to figure out the ratio. This is a probability. It does not tell you that 1 out of 4 kids. It's going to tell you 1 out of 4 chances for each kid. So make sure you understand that. How many big B's do we have inside the boxes? Inside, none. How many big B, little B's do we have? We have these two. So our number is 2. And then how many littles? We have those 2. The ratio is 0 to 2 to 2 for the genotypic. Phenotypically, it has to tell us physically something. They didn't tell us what the B's mean, but obviously the dominant trait has to begin with a B. I'm just going to use that as brown. So we're going to say there would be 2 brown. Again, I just made up that color because I know the dominant trait has to begin with a B. And then there would be 2, let's just say, pink. That would mean that big B represents brown and little b represents pink. And again, I just made those colors up. It doesn't matter. It's just you have to know that phenotypically it's what you would physically see. So the ratio would be 2 to 2. Getting to tomorrow's activity. I said this was going to be a short video. I lied. You already know Miss Wong can talk. Solving genetic problems. These are the steps of how you should process every single Punnett square no matter what. First thing is to figure out which one is dominant, which one is recessive. Up here, we have a big T and a little t. We're just going to assume that we're talking about tall and short. Why? Because that's the basics of what we've been talking about. Parental genotypes. It does not matter what we're writing in this case because it's just going to tell you to figure out the parents, make the Punnett square, get the ratios, and so on. So, number 1. Again, this was just a sample of how you're going to follow those instructions. You follow all 5 steps for every single one. So here's where we start. It tells us here round seeds are dominant over wrinkled. So what's our key going to look like? Big R. Why am I using an R? Because of round. Big R is going to represent round. Little r is going to represent what? Wrinkle. Monohybrid, one letter and one letter only. The cross, what is our cross? It's here. Pure means what? Same letters. Again, pure, that's recessive. So pure recessive versus pure dominant. And what do? We come over here and we fill in the boxes. Big R, little r, little r. How did I know what the crosses were? It says a cross between a pure round seed and a pure wrinkled seed. And then I fill in my boxes. Genotypic ratio. We're going to look for how many big. There are none of those. How many big littles? There's 4 of those. And how many littles? None of those. Phenotypically, we're going to look for how many round versus how many wrinkle. Round would be either big R, or big R, little r, because they both have a capital. And wrinkle can only be little. How many bigs do we have? None. How many big littles do we have? We have 4. How many littles? We have none. So the phenotypic ratio is 4:0. You have to use these words to tell what the cross is. Hetero and hetero, both of those are going to be big, little. Green is dominant. So therefore we're going to use G's. Big G, little g. That's it. As you're going through these, again, how do you know the genotypic and phenotypic ratio? It is written right here. Homozygous dominant, how many bigs? Heterozygous, how many big littles? And then homozygous recessive, how many littles? Please Google Meet me if you need me to explain whatever you're doing. Or send me an email, send me a screenshot, send me a screen record, send me a voice memo. I miss you guys. Hopefully you're staying safe. I know my allergies are kicking my butt.